work in your groups. Hopefully we're making some progress. I sent out an email this morning that Near Space Launch is doing a balloon launch on Saturday. And so they actually came by and got our JM board, so it's going to fly. Yeah, I know, I got it. And so that's kind of a big deal because really it's untested. And so basically it's going to be, they already have a payload for it. They're going to send it up, it'll come down, and then it'll have an SSD, or not SSD, they'll have a memory card that will have the data for it. And so we'll have an opportunity to see what they collected. James Smith will also share his coding data for what all he gathered, so that'll have direct application for a lot of you and the sensors that you're wanting to use. Jeff and Isaac are going to talk a little bit about what they've been doing with the Gridi, which they were working on that on the previous satellite and initially ran into some roadblocks and just abandoned that. And now they picked it up in conjunction with their project that they're going to talk about. So without further ado.
There we go. Popped up for a
Wait,
second.
what detected?
I'm going to give a little intro on this while Matt, you guys working.
Go ahead and take your mask off.
Oh, yeah. Okay, so the Gridi, as you probably remember, is the 8x8 infrared grid sensor. So we basically see a very pixely infrared image. And it is I2C based, so that's just a transmission protocol. And so there's a parallax library for that, and so you don't have to worry about that. So I figured out how to read from the Gridi, and then there's a few settings that I'll have to mess around with and tweak. You can change like the frame rate and whatnot. And then I figured out where the pixel values are stored. They're stored as 12-bit numbers, so there's 2 bytes, but then they're only 12 bits, so the top 4 bits are just 0 padding. And so I read the pixel values, and then this function right here, to get pixel temp, it takes a 2-byte value, and then it so the format is just like the top bit is the sign bit, and then the bottom 11 bits are numeric values. And so it does some bit manipulation to turn it into an integer, and then it multiplies it by 0.25 because the bottom 2 bits are just decimal places. So so this is a conversion to degrees Celsius. And then obviously, if you want it in Fahrenheit, you can do a conversion. And so that was the first bit. And then I also, so the next step after I have the image is that I need to do some image processing. Well, first of all, I guess. So if I comment that and restart it. Alright, so now it's printing out the 8x8 grid in its hex form. And so as you can see, there's 8x8, each one of these is a different pixel. And they're all in the, all in the 40 range, hex 40. So if Isaac puts his hand in front of it, as he is, the temperature on it goes up, and that would go from about room temperature to like high 80, lower 90 degrees. And so that is how the sensor works. And so from this, we could just send down the raw values, and obviously I would want to cut out the zero padding, because that would be wasted space, so you can save like 33% if you cut out part of it. And then, so we could just send down the raw values, but we also want to do some image processing on it to determine if it's a good image to send. Because obviously if you're just sending like a very flat monotone image, that wouldn't be very exciting. But if we saw like the boundary, like the horizon, you'd expect there to be a bunch of cold values where there's space, and then a bunch of hot values where there's the earth. And so if I comment this out and then I do this. So I downloaded just a small little image processing library off of GitHub, and it has canny edge detection. So as you notice, now it's mostly all zeros with a few FFs in there, and it's basically a binary value. It's either 0 or it's low or high, and it's determining if there's an edge in a particular spot. So if there's a high contrast area, then it'll give an FF. So like if Isaac, you put like your hand a few feet above it, then you'll notice like right in the middle here there's some edges, and that's where his hand is being detected as an edge. And so that's going to give us some good information about whether an image is good quality, and then I'm going to continue working on that and write a few more algorithms to improve the detection of whether it's a good image. So that's basically it. Any questions on that? Great. So you can all get into your teams. I'll come around, see where you are as a team, what your plan is, and then ask what you need my help with in order to achieve what you want to do with your group. All right.
Cool.
So, yeah. Great.
Does anybody have any questions for Jeff? Does anybody right off the bat already know that, hey, I need some help, I need some resources? I mean, I know the engineers that got it, they're already done, they're just here just because. Physics and engineering.